This is the final part explaining the GroupedObj class. Um, I decided, because parsing of the file is actually very slow, especially as you saw earlier on that there's a million lines of OBJ files to read in. So it's quite important to be able to save and load this data in such a way that it's very quick. So I decided to write some serialization code to do this. So there are two methods, save binary and load binary. And the job that this does is to take the contents of this class and serialize it in such a way that I can write it out to file very quickly and, more importantly, read it back in very quickly. So we're using the OFStream class for the output file, and the first thing I do is I write a header to the file so that I can check to see when I'm loading in that it is actually the data that I want. So it's quite a simple method, by no means foolproof, but I've chosen a key that isn't being used for something else, so ngl :obj bin, and I write that as the first few bytes of the file. That will then get read in later, and we'll check to see that they are the same thing. After that, I need to write out the individual elements of my mesh data from my stood vector of meshes. So first thing I do, get meshes.size, and I write that to the file. So when I read back in, I read that data in, and then I know how many elements I need to read. So then boost for each of the elements through, and it's the same thing. A lot of the time we're writing out things which are strings, and obviously we don't know how big a string is going to be. So first thing I'm going to do is find the length of the string, so use the length method on stood string, it will return the length, and then I write that to the file. After that, I write the actual text within that string to the file as well. So we've got how long it is and the actual data, and that's repeated for all of the elements that are string based. The other two are just unsigned ints, so they're always the same size, so nice and easy to write out. Now after I've done that, I need to grab the mesh data and export that information. So I'm literally going to dump the entire contents of the vertex array object back into the file. So the first thing, I have a method in the vertex array object class which will allow me to get the size of the class. So what this does is it ensures that the vertex array object is the currently bound 1, and we can use glGetBuffer parameter iv, pass in array buffer and buffer size, and that will give us back the size of that data in bytes that has been stored in the vertex array object. After that, I'm going to use another function which is actually part of the abstract mesh class, which then hooks into the vertex array object itself. So in this class here we have a map VAO verts. What this does is it binds the vertex array object, then it calls a bind buffer and grabs the vertex buffer object and uses glMapBuffer and the mode that we want, read and write in this case, to basically return a pointer to the beginning of the vertex array object data. Once we've got that, we can copy it directly to the file. So basically this is the data here, my VBO mem, and I just grab that data and write it out to the file. I've just noticed that I'm unmapping it in the wrong place. I should do it there. For some reason it doesn't matter. I think that's just an unbind, but in theory it should be that way around. I'll change that. And that's writing the data out. Reading the data in, very similar. I clear the data structures first. I read in the 12 bytes of my header, and I make sure that it's the same as was written out. And then the reading back in is more or less the reverse of the writing out. First we read in the size in bytes of the string, then we resize that string, so that we've got enough area to copy it into, and we use the index, the subscript operator there to access that data to read it in. Finally, we need to recreate the vertex array object. So I'm creating one from new, I've got my data pointer, I read that data in, I close the file, then I go through and I create a vertex array object, I bind my mesh, go to mesh size, and I'm going to recreate. So first I set the data, there's my vertex data there, then I need to bind my vertex attribute pointers. Now, in NGL internally, we virtually always use this structure. So we've got an array of UVs, an array of normals, an array of position. I've used this structure because it's legacy from one of the OpenGL internal formats from years ago, and GL Debugger used to display this, so it made it useful. It's most probably not as useful nowadays, but I'll keep it here for now until I do a major refactor of the code. So what I'm doing is setting the vertex attribute pointers inside that data so that the correct vertices are mapped. Set the number of indices, unbind the mesh, and we're ready to go. And another good thing about doing this is I've noticed that I've allocated vert data there, and I've not freed it, so that's something else that actually doing code reviews and reading this is actually very good for, that I can add that now and delete my data there. So that's it now for that class. We have methods to read, we have methods to write in both normal and binary, and then we have methods to go through and draw and actually use this class. The draw is relatively simple. As you can see, I bind the mesh, I make a call to draw, which we pass in the start index and the number of vertices to draw, then we unbind the mesh. And I'll be showing that in the next example.